Okay. There we go. More or less. All right. Today, we're going to try to follow Nick's Voxel blog and attempt to implement dual contouring. However, he is using octrees. I am not. So, yeah. Let's see if we can figure this out. Corner position, because it depends on how he's doing this. Construct octree, who cares? Child min offsets. Needs to match vertmap. Yeah, this is where it becomes a little bit like... Very bright. Okay, so it's there, there, there. There. Okay. Yeah, there, there, there. I guess it depends. If Z is up or if Y is up. It's creating an SDF of a sphere. Even an origin. I'm kind of sick also. We'll see how much we can do. Well. Dual contouring relies on Hermite data. Can approximate this with this and blah 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 blah. Finding the rate of change using the zero crossing position. Position of the surface on each edge is a base. We can measure the density values on each axis either side of the surface to determine the rate of change on each axis. This I'm not so sure what's going on. Page 0.001 E 0F 0.F. What the fuck is density? The fuck is density funk? Oh, this is the one I was looking at before that I didn't really understand anything about. Density funk takes a world position, const float, max height, noise, fractal noise. Well, I feel like we just gotta implement shit. And see what happens. Yeah. Fractal noise. I don't really understand it, so we're just gonna copy and see what we can understand that way. Lacunarity? Of course. But I don't think I need this noise function. Like, what is this? Is this the density func? That's just the noise. Calculate surface normal. That's a position. DXY. What is he doing? I don't understand. Look, dx equals density func p plus vec3 h0f0f minus density func p minus vec3 h0f0f. That's just 0. Huh? I'm confused. But I feel like I need to do this. Like, I need to calculate the surface normal. So that can be done by calculating neighbors, right? Like, that's how that works, because I do think that you need that surface normal. Maybe. And in this case, he's doing some bullshit. I'll be honest, this piece of code here is, to me, complete bunk. This doesn't do anything. Oh no, it's plus and minus. Never mind. Okay. I see what it does now. Here it's plus, here it's minus. Yeah, I don't really understand this. I don't care about all of this octree bullshit. I just want to set the values on the voxel. If the density value at the corner position is negative, the corner is inside the volume. Otherwise, the corner is outside the volume. If all the corners are outside or all the corners inside, the volume node is discarded. Otherwise, we need to determine the position of the leaf node's vertex. I don't know if I can do it with the way I'm doing things now. I don't know if I can just slap it in. But it's not so easy when it's designed for another BVH. Because they're determining corners and stuff, right? But that should be determinable based on the normal. Didn't it? Approximate zero crossing position. With all edges evaluated, the gathered positions and normals can be fed into the quadratic error function. Reading about the QEFs in the dual contouring paper was off-putting. I didn't understand the maths and had no idea how to implement it. Thanks to the reference implementation, I didn't need to worry about how to implement it. This sample contains my refactoring of the original implementation, which makes it a bit easier to use. I don't... Let's not bother reading that. The QEF is initialized using the positions and normals and then solved. The solve function finds the position for the vertex with the smallest error. I.e., the vertex is placed as close to the surface as possible using the supplied inputs. The normal is calculated as an average of the input normals. The corners variable is stored as this is used by the contouring algorithm. And the nodes type is changed to a leaf. Once all the nodes have been evaluated/constructed, the octree construction is complete. Once the octree that I'm not using is constructed, we can generate a polygonal mesh to send to a graphics API. The reference implementation provides all the code for this, which makes things considerably easier. There are two variants of the contouring algorithm provided by the original and no intersections variant in the sample code. If in the sample is code I've refactored from the simpler original variant. The C++ isn't helping, but I kind of understand C++, not entirely though. Like consts are, it's so strange to me that they use consts and stuff so much in like parameters and whatnot. We'd never do that in C#. I don't know what that's about. It's a const and it's a reference? I don't know. Generate mesh from octree. No, that's a very... Yep. If node return vertex buffer clear index buffer generate vertex indices contour cell proc. Contour process edge. Arbitrary big number. Int indices for bool sign change. Process edge mask. See, I genuinely don't like making functions too much. I think it makes the code harder to read. Like, it makes the code easier to understand and like digest for yourself. But I feel like trying to understand what's happening when there are just a bunch of function calls is really difficult. Because you have to go and like check everywhere, like what does this do? What does that do? What does that do? Process edge mask. Direction I. Edge vmap edge 0. Octree node. Firstly, each of the 4 neighboring nodes are processed. Process edge mask array. It's also funny trying to actually find tutorials and stuff like that, because it's so often that you read a tutorial like this and it's just like 100 pages. And then you just stumble upon like one GitHub page and it's like this much code and it's actually like the entire implementation and it just works. That happens all the time. But there does seem to be a lot of steps involved here. I feel like I just gotta get past the initial... No spooky game today? No. The only spooky thing is how runny my nose is. How are you doing, Despes? Was celebrating my mother. Got a Halloween birthday. Yeah, that's good. I am snuvig. But otherwise, all right. Trying to understand where to start here. Because I know there's the octree shit here that I don't need. Now this here we have some bird maps, which makes this is a little confusing. Here he's creating a sphere. I don't need that. Calculate surface normals. I feel like this entire thing is not what I want to do. Because for me, I feel like it's a bit different. Can now create the leaf nodes for the octree. I feel like this is also kind of bullshit. If the leaf node contains the surface density func. If the density value at the corner position is negative, the corner is inside the volume. This is, I think this is kind of where it starts, really. And what I think I need to do is I need to generate that. I need to, for every voxel, I need to sample all of its neighbors. And I need to generate the edge vertices, or the corner vertices. I don't know if I need to generate the edge, but maybe. I'm not sure. Because that's the only way to determine whether the corners of the voxel are within or not. Because we need to interpolate between its neighbors and itself to figure out what the volume is at its corner. Because it doesn't have a corner. It's just a voxel with a volume, and a lone voxel with a volume. The neighbor that also has a volume. How do I handle the corner? Or like, how do I handle the edge of the world? I think I just don't. Because the edge isn't supposed to exist. Like, I'm not supposed to ever get to it. So it doesn't really matter what happens there, as long as it doesn't look weird. But I feel like I just, like, this is bullshit. We don't need this. What we need is I don't think we should store the corners. Like, I feel like the entire algorithm should run on the one voxel. That's why Yeah. I'm just gonna call this public void dual contouring. And we're gonna take X, a Y, and a Z. I have to do pretty much exactly what I'm doing over here in the on the GPU right now. Think. See, it's a little tricky because maybe I should run this on the Perlin noise right away. Maybe that makes more sense. Like, I don't want to use Perlin noise, but maybe it makes more sense. Because the reality is, I do want to generate using a noise map, but I want the noise map to be generated in a different manner than the Perlin map or the Perlin noises. But at the end of the day, we should end up with a noise map that we should sample from when we generate new chunks. So maybe it does make sense to use the Perlin noise here. I'm not sure. But it's still not, like, it's not 3D. But maybe that doesn't matter. But I also don't know if I feel like it makes makes a difference. Yeah, it makes one difference. There's one key difference that it makes. And that's the corners. So one current issue with my current solution is that if you have a bunch of voxels here, the reality is that when I try to turn these into smooth terrain, we're missing information here, and here, and here, and here, and here, and here. And that's the information that I think is critical, because this is basically the way I'm doing it now is that I'm using the Perlin noise and then I multiply it by the world height. Because Perlin noise is between 0 and 1. So if the Perlin noise is at 1, then we generate a mountain that's as tall as the world, right? And if it's 0, then it's just minimum. And I then have a cutoff point for the voxel generation that says, like, if this is, well, I'm basically taking a certain decimal and I'm saying, well, because we're multiplying it by the world height, we do get a decimal, right? So we might end up at like 33.7 or something. Then I take 33 and I create 33 voxels up. And then I take the decimal and I create the last one with a decimal volume value. Right. And because of that, if we're at like 33 exactly, then we're not going to generate a voxel here. But that's the problem, because that should be a voxel. The voxel that's at the value where it has 0 volume actually has volume. And the reason for that is because its neighbors might have volume. And because its neighbors have volume, the average volume of the corner is greater than 33, which means that this voxel here, while it has a volume of 0, the corner does not have a volume of 0. The corner has a volume of something else that ties together everything else. And that's the issue there. And that's the issue here with, if I just try to use my voxel data to do this, that means we're going to have to test every empty voxel anyway. No. I think it doesn't matter. I'll have to like do it anyway. Look, we'll have to add a new voxel there, which is fine. It's just we have to do it. I mean, I feel like I have to generate the voxels first, and then we run the dual contouring on it. I feel like if it has no neighbors, then we don't run. That's like the only scenario. Also, I wonder what kind of shape you'd get with this algorithm if you have like this. Is this just gonna end up being a square? Or what is that shape gonna end up being? I think this wouldn't exist. Because I think what's gonna happen is that we're gonna have I think what we're going to be generating is something like this. Right? And then here, this is going to end up being like this. Here we get this. This should be the final shape. The outer line here. At least in theory, I think. Still a little confused. Because we're supposed to calculate the normal for the corner. And the normal for the surface. But in this case, it's the surface is in the middle. if the density value at the corner position is negative, corner is inside the volume. So what is he doing there? He's getting the density func of, like, this is just age equals 0.001. So he has P, which is a position. And then he adds 0.001 to it. And then he subtracts P minus 0.001. He's just fetching the difference. Like he's just trying to get to the change, the delta. And he's doing that for the surface itself, not for the corner. So first we want to do the surface, which is just checking the cardinal neighbors. Right? And then we subtract that. We check the volume there and we take our volume and then we subtract that. Maybe. Is that would be density? Kind of. Calculate surface normal. First step is to determine whether the leaf node contains the surface. Corner position, leaf, arrow, min plus child min offsets. Where does this come in though? Calculate surface normal. And he is getting density here. So he is checking that for the corner. And I think that means that we do have to calculate all of the corner neighbors. And getting the average of all of those. And that's all 8. But I honestly don't know. If density is less than 0f, then solid, otherwise air. I don't understand how he's getting a negative thing here. There are honestly not a lot of write-ups about it. I don't know what to use anymore. Like, is it the universal 3D or the built-in one? I don't like these render pipelines. Okay. No. Are you done? I mean, I don't know which project that's looking into. Thank you, Alba. Come on, man. What? The project is using the new input system package, but the native platform backends for the new input system are not enabled. No. Okay, there we go. So here we have a pink terrain rendering with no controls, nothing. Okay. Root build octree. Generate mesh from octree. Generate vertex indices. You kidding me, dude? Generate vertex indices. Huh? Oh, this is some kind of recursive bullshit. Vertex buffer. New mesh vertex. Draw info position. Draw info average normal. Vertex indices. I feel like the octree is really just making all of these examples a lot harder to understand. The octree is a really complicated BBH. I don't like where are you even calculating normals and shit? Build octree. Construct octree nodes. Simplify octree. What does that even mean? UEF. Average normal. I mean, I guess technically I could make the world be octrees. Because the Raymarcher doesn't need to have the octrees. Because part of it is... I mean, I don't know. The brick the brick map is simple, right? Like, you just look at it. If it's 0, then you're good to go. But I guess it's not really that big of a difference between the brick map and the octree at the end of the day. Because the brick map solution is supposed to be simpler. You just have a brick, and it just contains all of your voxels in that one space. Because that's the main difference, right? The brick contains 8 times 8 times 8 voxels, and in the first layer. While the octree, you might need to go down several layers to get to where you want to go. Maybe 3 layers. Because you have 1, then you have 4, and then you have 8. Right. And in the octree, you have to access the octree, and then access the next layer, and then the final leaf layer. Right? While in the brick map, they're separate, or they can be separate. Where the brick map is just like a representation where we flip a bit switch, and that's it. And we don't store the voxels in it or anything like that. It's just a representation of data that exists. But an octree could be converted to a brick map for the sake of the GPU, right? Like if you store everything in octrees with 3 levels, and that's like a chunk, I guess. Or maybe it should have 4 levels or something. Because that would be 8, and that would just be 1 brick. But I would like it to be a wall. So I don't know if that's 4 levels. No, that would be maybe 5 or 6 levels, wouldn't it? To get it to be 64 voxels in one. Or 64 times 64 times 64. You'd have to subdivide it 1, 2, 4, 8, 16, 32, 64. So that would be 7 levels. But that also means that you have to access all those levels to reach the leaf, I think. Which in the CPU probably doesn't matter that much. We're not really, I don't know. I kind of don't like the octree solution. That's why this is just really confusing for me. Because everything is just done with the octree. This is all just recursive code for the octree. generate mesh from Octree. Vertex buffer. I think I've actually seen this before. Oh yeah. Yeah, I have, because I read it like yesterday. First we use an Octree. God damn. I feel like I don't need much. I feel like I just need... This is what we need to find. We need to find the isosurface. I know how to do it. I do. I'm just trying to visualize it myself and figure... right? Here, it's not necessarily as simple as a full voxel is below the isosurface, because this here might cut through. Anyway, if there's no corner there, because here we then need to get the edge value here, here, and here, right? I think. Eight plus 1 divided by 2. That's 4.5. I can't write that out here. Issue with pixel art software. But does that help me? And then here, this is 5.5. Right? Then what about the corner here? That would be 3 plus 8 plus 1 divided by 4. That's a 3. Wait, hold on. Well, no, not exactly. See, here's an issue. I think it's been a little bit misleading, because I feel like what they're talking about is, because it's volumetric data or whatever, we're trying to find the surface, and like whatever is inside of the ball is denser than outside. And therefore, when we check like inside versus outside and subtract that, they get a negative value. That's what I'm like struggling to understand here. Like they get a negative value, but I feel like I can't get a negative value. I can get a 0. And a 0 is kind of my negative value because if we take these two here, right? This is 8 and 8. If we get the surface normal here, that's by adding these two together and then subtracting. That way we get 16 divided by 2, that's 8. So we have 8 here at the corner as well. Which means that if we take the target, we subtract the edge, or we take the edge and we subtract the origin, which is 8, then we get 0. And that means that this is either outside or inside. Kind of. And if each corner does that, and we end up with 0 on each corner, that means that this is not a surface and we discard it. So here, I mean, that's all it takes to get a normal, right? You just point it. So here, but I don't really understand entirely. Because here, right, if this is 4.5, does negative mean outside? Because that's what this would mean to me here. Because here, if we take, this is the target, then we subtract the inner, then we get negative 3.5. I don't know what that means. I don't really understand this part. I feel like we're getting further, but holy shit. Points inside the sphere will have a negative density. And points outside the sphere will have a positive density. Right. So that's what this means. This is inside. This is minus 3.5, so we have a negative density. That means that this is inside. Using the corners of the leaf node's bounding box as input to the SDF allows to determine whether any of the edges of the bounding box contain a sign change, i.e. one end of the edge has a negative density value and the other has a positive density value. If an edge has a sign change, then that means the surface of the volume crosses the bounding box edge. If any of the leaf nodes have at least one edge with a sign change, then we create a vertex for the leaf node, otherwise the leaf node is discarded. Okay. I understand that. So then we do the same thing here. But does that make sense? 8 here, then this is 3. 3 minus 8, that's again a negative value. Is it saying that none of these corners would... Like, does this not have a crossing? Maybe it doesn't. Because that's kind of what that says, right? This would end up looking something like this or some shit. And then this one here would actually have a crossing here that would then end up, you know, going over here. This would go down. This here would cross over like here. This goes down there. Like I think I kind of understand how it works. Like I think it would be something like this. The 8s would not be intersected here, while the outside neighbors that have 0 would be intersected. Which is a little scary, because that means having to check every air tile as well. Like, there's no easy way to say, oh, this has 0 volume or anything, we can skip it. No, you have to check them. If they have any neighbors at all, you have to check. And it's a pretty heavy check. But when it has been done, that's like okay. I guess what I'm struggling with is this. This, like figuring this here out. Where do we actually get this normal from? I don't really know how to do that. I haven't really been messing or doing anything with normals so far in my entire career, up until we started doing triangle intersections. And at that point, I only figured out how to do a cross calculation. You don't know how to do this, Albine? Man. I don't know either. A normal is just it's just pointing in a direction, right? But it should be pretty simple, really. It's just like the difference between this point and that point creates the normal. So this is 4.5, that's 3. But I don't know how to get this value. If that's just like the cross product between this and that. But even if you do that, that needs to point in a certain direction. So I don't know. Because here, for example, they have a straight line here and there. I kind of wish it wasn't so uniform. That would help understand more. Because it's like the reason I think it's a bad example is because these are all parallel, which means that I can't really tell what the normal here means in the middle. Because it's just pointing in this direction, just like everyone else. But like if this point here was over here somewhere, how would this normal point? Would it be like, is this normal, the cross product of like this and this of its neighbors? That doesn't make a whole lot of sense either, because I don't have access to that there. Let's read through a bit again. Are these normal? Sure what you mean. Geometry normals? Yeah. Like I can get a normal for a triangle. I know how to do that. But these aren't necessarily points. That's my brother. Maybe I should just ask ChatGPT. But maybe it is just a cross product. Because you have a point, right? Like you have a point in the middle, and then you have the edge and the corner, and those actually have positional values. So maybe I mean, maybe I should just triangulate those and like give them. I don't know. Like, do I apply the value that we get as a magnitude to something, or like I don't know. I don't get it. My brother was useless. He forgot it too. I mean, it's Googleable. I just don't know if I just don't know what I should be doing. Here they're already talking about the QEF, and I don't know what the hell that is. Who's ahead so fast? At the leaves of the octree, we tag those edges with sign changes by exact intersection points and their normals from the contour. Is here, right? This is 8. 4.5 minus 8. That gives us a negative 3.5. Well, here, if we do the same thing here, we get positive 3.5. And what I was thinking is that if that's the case, then we can apply that as a magnitude to this normal, or to this position, just using the normal, just pointing out in that direction. And then we could step out that side to like a position here. But what I find confusing is this how I should be doing it? Because here we would get a sign change, because this here would be positive, and this would be a negative value, I think, over here. Therefore, this would be a negative corner, and this would be a positive corner. No, the other way around. This would be a positive corner. This is a negative corner, I think. And therefore, we have an intersection here. And by doing that, what you can get is you can generate a quad here, right? Because this is also positive, and in this scenario, this is only 2D. But that means that we know that it's intersecting here and here, and therefore we can generate a normal using like those points there, based on that quad that points out there. But that's what's a little confusing to me, because here they have a normal here on this intersection here. Which is based on what? Like, is that just the entire quad that they're placing here? It's just it's just like a central normal that they apply to the edges, to both of the edges. I don't understand. I feel like there was a better article here. Hello, Albine. We had this one. Extrapolate normals. And see, here he just starts talking about normals. I don't know. Maybe I'm stupid. And here, though here it wouldn't matter, but it does look like the normals are based on the entire surface, basically. So here, this point here would actually have a normal that points in both directions here, like up and down. But because they meet, it doesn't really matter. That's why I feel like this is a little bit misleading to some degree, because this isn't like actually the normal here. It's just that this is an edge. I was thinking of trying to make mini games, but I ran into the issue of how to handle the player controller for the different game modes. I was told to make the player controller a separate script for each and load it in the player script into each scene. I don't understand what the, like, it depends on what you're doing. Like, what's a minigame? Like, what are you doing? Because all you need to do to, like, switch what's happening is, like... Because you can have a script on every single object in the game that just takes input and works exactly like the player controller. But you can just set it so that like it only runs if it's assigned to something, or like a boolean is flipped, or like if you have a main controller that just controls the entire game, then you can just have like a game object there that, like a game object field, and that's like current player object, and then you just change which object is the current player object. That way you don't need to have like a controller or like a player input component on every object. You can just have the player input component be part of your main script, and then you just plug in the object that you want to be affected by the code in your main script, right? But that is assuming that you want the same controls everywhere as well. But you could also have like a switch inside of your controller script that just says like, it's like a boolean or like a mode switcher or something like that, that just changes how the controller or the currently assigned object is controlled. Right. So you just write a script like public handle movement input, and then here you have a void, and then there you have game object, current object, maybe, or maybe not even that. Well, you could do that. Right, and then inside there you just say current object, and then with whatever, instead of being just like this object's position is changed, you change that object like that. That's fine. That's probably how I would do it, I guess. Yeah, I don't know. ChatGPT. I don't even know what I'm asking. Like, how do I calculate? No, because calculating the normals of a point. Because what we want to do. I mean, that's what we want, right? It's a cross product. I just hate that they write it so simply, like they just gloss over everything. I feel like it has to be a cross product. We find the intersection edges, and then we find the normal using cross products. I guess. Because what I find strange, because it's how to handle like the edges and stuff. I don't know. It's this that I need. We're not gonna get to coding today either, man. This is too hard. This is fucking hard as hell. Compute gradients. Trilinearly interpolate to the Hermite points. Normalize. And use those normals as your Hermite normals. I don't know. What is a Hermite point, asshole? A point where the iso surface crosses a grid edge. Okay. Yeah, I mean, I think I'm just right. We need to get the edges where it exits, and then we calculate the normal using those. I don't exactly understand where this QEF thing comes in. That's this. But see here, like, why is this normal pointing here? In this scenario? Oh. Because here I would think that this is creating a surface here. This is creating a surface here. Octree, man. I hate it because it's like 90% Octree code all the time. Fuck off. It completely obscures what the actual algorithm actually does. It's horrible. I don't understand why they insist on doing that. Map x plus I divided by 4, y plus I divided by 2, with a modulo 4. I find this extremely confusing. I don't know what this is. What is this technique? Like, I get... Like, if we go back up here again. Like, this goes from 0 to 7. Which means we get x plus 1 at most. So we never get 8. When we're at 4, we get x plus 1. And here it's y plus I modulo 4 divided by 2. which means we're gonna get 0, 0, 0. No, we get 0, 0, 1. 1, 0. And here we get 0, 1, 0, 1, 0, 1. I guess this is a different way to just do this assignment or something. Like setting all the corners or some shit. Yeah. So this would write... It would write like this. 0, 1. 2, 3, 4, 5, 6, 7. That's what we're writing. Fair enough. But you know what? This is way harder than I thought it was going to be. But we are moving a little bit closer. I kind of understand, but I don't. This is actually a good implementation. Is this John Lin? Yeah, fair enough. I think because this says uniform, right? Which means something. This says adaptive, this is uniform. But the only difference here is that the adaptive one has an oct tree. Well, there's probably more differences too, but that's like the main thing there. Dual marching squares, what the fuck? So here we sample init data. This is where we build the... Here he's doing what I'm doing. This is think a solution. I think this is generating a voxel terrain, more or less, or the voxel data. Or like I thought, but here we're running generate at map. And this is where I find it a little bit odd, because here, what he's just... What is this? Because if that's the case, then here he's just reading like over there. He's just reading like one corner. I mean, maybe that's the point. It's basically saying that we're generating here. That's what it's doing. So it takes a point and it always generates in the top right. Which there might be some sense to that. And maybe you operate on 4 voxels at a time or something. I don't know. I don't get it. Outline location. This part I don't understand at all. We have 12 edges. We're iterating through the edges. And here we now have some kind of edge order. Where did the edges come from, man? Here. Okay, so the edge is two points. So it's 0 and 4, 0 and 2, and 0 and 1. Corners. If map is less than 0. This I don't really understand. Like here we're sampling, right? We're sampling a sample, but I don't know what kind of values he's getting here, but he's generating a value here in the map. And here he's checking if the map is less than 0. What does that mean? Less than 0? Is that empty for me? Because then that would be 0. Or... is he like calculating? Like, I don't really fully understand. But is he like treating the corner as like the point? Right? Because this is what I find strange. Like, if you do this, because this is what he's doing here. He's picking out 8 voxels. In a 2D scenario, that would be 4, right? And then he's like setting corners based on the value inside of that position. And to me, that's like what the fuck is that? But I guess it makes some sense if you think of it like being like this instead. And we're actually testing this point here in the middle. And therefore, this corner is 8, this corner is 3, this corner is 1, this corner is 0. I guess? Like, is that what's happening here? I don't know. It's just like fundamental things that I don't understand what he's doing, and it makes it really hard to understand the rest of the code. Because, like, within that context, I feel like this makes more sense. Because here he is going through the edges. That's what's happening here. And here he's checking the corners. for each edge, right? So I understand what's happening here, I think. Basically, we're checking this one edge, and each edge contains 2 indices, and the indices is each corner. So then we're checking M1 and we're checking M2. And we're basically fetching the corner and we're checking the first bit to see if it's true or false. And if they're both the same, that means that there's no intersection on that edge. Otherwise, it continues down here to this bullshit. Take care, Bino. And here, we're getting the density. We're getting the density of 2 voxels here. Which then has to, like, it has to be that way. Because now we're getting the density of the corner that it belongs to. So we're getting like this, and we're getting this density. P1, P2. P1 divided by 4. So complicated. Just get normal. Just like that. That's just how you do it. Just get normal, bro. That's simple. Just get normal. Yeah, this completely... I don't know what's happening here. This is bullshit. Sampler.get intersection. What the fuck is that? It's generating a contour here. I don't really understand what's happening here. Like we're generating a contour. I don't understand the kind of data that's being stored here. Or what's happening? Vertex count plus plus. Vertex indices equals vertex count. E20 equals vertex position color normal. I have no clue what's happening here. This is the kind of code where I'm like, nothing is happening here. Nothing is being done here. Set data. Just don't understand. DV. Color. V2. Vertex buffer, set data. This is like the only thing that happens here. Vertex count. What? Isosurface algorithm. What's this bullshit? Draw a wireframe. Oh my god. List of vertices. So it's just writing the information directly to the buffer. Happy Halloween, Q Slime Girl. How's it going? But I think we're gonna stop here. I don't know how to handle this. I don't know. I don't know what I should be doing. I don't understand. Like, we're generating, and from what I understand is we're generating the isosurface here. But like, I can understand most of this here, down to and including this for loop. Kind of. I lose track of what's happening here. And this bullshit. But I feel like what's happening here is that we're calculating, like we're using 8 voxels, right? And we're working with the center of those 8 voxels, which is kind of strange to me. I guess, but that's what we're doing. We're operating on the corner in between all of those 8 voxels. Somehow. And then we have found the edges where there's an intersection. And then we feed that into sampler.getIntersection, and it gets the center point. Because that's just a quad, and it gets us the intersection at the center. And then it gets us the normal. We feed it in the X, Y, and Z, which is super I don't understand, because the X, Y, and Z is the bottom left corner. I don't understand this approach. X, Y, and Z plus the intersection sent to the sampler apparently gets us a normal. Huh? I can't tell where the drawing and the actual algorithm starts and ends. Here he's just setting bullshit vertex count and doing bullshit with just like a shitty mesh. Visualize it. We're gonna stop there. I'm gonna I'm gonna try Googling some more and reading some more maybe. And we'll continue tomorrow. I don't know if we'll manage to do anything tomorrow either, but yeah. Until next time. Thanks for hanging. Have a good night. Bye bye.